This is the third part of the lesson on line integrals. We will be dealing with, first, the arclength parameter, or ds, as the given variable of integration, and use the formula of ds. And second, x and y are given in terms of a parameter t. Let us learn how to evaluate some of them. Here are the objectives of this lesson. At the end of this lesson, you are expected to solve line integrals involving the arclength parameter ds, solve line integrals involving the parameter t. Let us have this example. So we have here find the integral of x times the quantity 1 plus 4y ds with respect to the curve C, where C is the curve y equals x squared, starting from x equals 0, y equals 0, and ending at x equals 1, y equals 1. So this is the same integral and curve as the previous two examples, but the integration now is carried out with respect to s, the arclength parameter. Let us now solve this problem. So we have here the integral of, we write it as the integral of x times the quantity 1 plus 4y ds along the curve C. So as we can see, we have here the variable of integration is ds. So what we're going to do is to replace this with a variable of integration, which is x. And how is this? So let us recall the formula of ds, or the arclength parameter. So ds is equal to, you have the square root of 1 plus the quantity dy over dx, quantity squared, times dx. So this is the formula for ds, and we will use this and substitute in the given integral. But then, how are we going to find dy over dx? So we have here the curve given as y equals x squared. So we're going to find the derivative of this function with respect to x. So this is now dy over dx equals 2x. So replacing now, or substituting now dy over dx equals 2x in the formula. So this will now be ds is equal to the square root of 1 plus the quantity 2x squared dx. And simplifying further, we have here now as square root of 1 plus quantity 2x squared is 4x squared dx. So we can now have replacement for ds, which is this radical times dx. Since this is dx now, what we're going to do is to replace y also, and that is in terms of x squared. So this will now be written as the integral of x times the quantity 1 plus 4 and y is equal to x squared. Then ds is equal to this radical, which is the square root of 1 plus 4x squared dx. And the limit, we have it as from 0 to 1, because we have here first value of x is 0, then the second value of x is equal to 1. Then simplifying the expression that we have here, this will now be equal to, you have, let's combine these two because they are similar. We have 1 plus 4x squared as the radicand here, and then we have the expression 1 plus 4x squared. So this is now adding the exponents. So we have here the exponent of this binomial here is 1. The exponent of this radical is 1/2. So we can now write this as quantity 1 plus 4x squared raised to 3/2 dx. Then from limits 0 to 1. Then let us now integrate. So how do we integrate this? So we're going to make use of the power formula by letting u equal to 1 plus 4x squared. Then getting its differential, so we have du equals 8x dx. So we have here x dx in our given expression. So we have the correction factor, which is 8. And a neutralizing, which will now be equal to 1 over 8. So we write this as 1 over 8. Then this will take the form of, you have this as u raised to 3/2 du. And this is also known to be the power formula or the general power formula. Let us recall the formula for that. So the integral of u to n du is equal to u raised to n plus 1 over n plus 1 plus c. But since this is a definite integral, we're not going to add plus c in our answer. So therefore, this will now be equal to u raised to 3/2 du. And then let's have the limit 0 to 1. So we have here now 1 over 8. Then you have u raised to 3/2 is, using this formula, this becomes u raised to 5/2. Then reciprocal of 5/2 is 2 over 5. From 0 to 1. Simplifying it further, we have this as 8 and 2 will cancel. So this will be 1/4 times 1/5. That will be 1 over 20. Then let us replace u now, or rather replace u by 1 plus 4x squared. Then this is raised to 5/2. By the way, this will now be du. And since we have replaced u to be 1 plus 4x squared raised to 5/2, your du will just now be dx. And by the way, since I already integrate, so there will be no more integration here. So I will erase this part. This one also. So let me again simplify in this manner. So we have here now the limit 0 to 1. So I have already canceled 8 and 2, that will be 1 over 20. Then this is now replacing u with 1 plus 4x squared. Then this is raised to 5/2 from 0 to 1. If I'm going to evaluate now, so this is 1 over 20. Then you have applying the limit first, which is the upper limit to our variable x. That will be, you have 1 plus 4 times 1 quantity squared. That will give you 5. 5 raised to 5/2. Then if I'm going to apply the lower limit, which is 0. So we have here now 1 plus 4 times 0 is 1. Raised to 5 halves is 1. So we can also write this now as 1 over 20. Then transforming this to be a radical. So this is now, we have it as square root of 5 raised to 5 minus 1. But what is 5 raised to 5? So we can also write this now as 1 over 20. Then you have this as square root of 5 raised to 5 is also equal to, you have this as 25 times square root of 5 minus 1. So this is the answer for this given integral. Let us have another example. So we have here, find the integral of xy dx along the curve C, where on C, x and y are given in terms of a parameter t by x equals 3t squared, y equals t cubed minus 1 for t varying from 0 to 1. So as you can see, everything can be expressed in terms of t. So we have here x is equal to 3t squared and y is equal to t cubed minus 1. And we can find dx by getting the derivative of this function. And then we have the limits available, that is from 0 to 1. So let us now solve this. So we have here now the integral of xy dx along the curve C is equal to replacing x by 3t squared and y by t cubed minus 1. And then let us find dx from x equals 3t squared. So if x is equal to 3t squared, getting the derivative of this function or differential, so dx is equal to 6t dt. So replacing now dx with 6t dt. And we have here the limits from 0 to 1. Then let us now simplify the expression. So we have 3t squared multiplied by 6t, that will give you 18t cubed. Then multiplying this by t cubed minus 1, this will be 18t to the 6. Then minus 18t squared dt. Then let us now integrate. So integrating 18t to the 6th dt will give us 18t to the 7 over 7. While here we have it as 18t cubed over 3 from 0 to 1. Applying now the upper limit and the lower limit, we have this as 18 over 7 times quantity 1 raised to the 7th power minus 18 over 3 is 6 times the quantity 1 cubed. That's the upper limit minus the lower limit. And that is equal to, we have this as, by the way, committed the mistake again here, this should be 18t cubed. So let me erase that part. So this is what I have. So this will be 18t cubed. So sorry for the technical error. So this should be 18t cubed. So integrating now, this will be 18t to the fourth over 4. So let's have this as 18 over 4. Then with the lower limit, so we have 18 over 7 times the quantity 0 raised to 7 minus 18 over 4 times 0 raised to the fourth power. So this will give us 0. So with that, we now have 18 over 7 minus 18 over 4. So simplifying this, we have now, using your calculator, so the answer here now is negative 27 over 14. So this is the answer for this given problem.